Hi. Alright, okay, let's look at this question. So you can pause the video and look at this question. Right? Okay, try this question. It is known that 10% of the patients with high fever are confirmed to be suffering from dengue fever. Means that most of the case that 10% of the patient, the high fever because of the dengue fever, right? So look at question A here, right? They're given you a sample, right? There is a sample here, 15 patient, right? 15 patient, and the probability of the fever is come from the dengue fever is 10%. So this is a binomial distribution, right? It's a binomial distribution, which there is a number of patient, right? Number of patient. So means that you have to know that you can know that there is a 15 sample here, right? 15 sample, and 10% of the patient have high fever, right? 10% is correspond to 0.1, right? 10 divided by 100 are confirmed suffering from dengue fever. So the X here is represent the number of patients, right? It's a discrete random variable, right? It represent a number of patients. Okay, number of patients. So number of patients that suffering from dengue fever, alright? So it's 10%, right? 10%. So the question is asking us to find the probability, right? This question is actually involving a small sample, right? Something less than 50. 15 only, 15, right? It's less than 50, right? So we can just using binomial distribution without doing anything. So then they find the probability that less than 6 are confirmed to be suffering from dengue fever, right? Less than 6. Okay, means that number of patients is less than 6, right? The number of patients is less than 6 out of the 15 here. So we can using statistical table. Right, we can using statistical table 1 for binomial distribution, right? Because we can they ask us to find the probability of x less than 6, so we can using table 1, table of binomial probability. So I hope you still remember how to using this. First, you see if the sample is 15, right? 15 and 0.1. So you can find from page page 6. Okay. 15, the number of sample is 15, and the probability is 0.1, right? So this section here, right? This section here. So this is for 15, 0.1, right? So now I want to using this part, the number here. So how to doing this? So we have to modify, because the format, right? The format in your statistical table is greater or equal R, right? So this one, you should convert it become greater, which is 1 minus px greater or equal 6, right? Why is it? Because less than 6 means 0 can be none of the patient is suffer from dengue fever. 1, 2, 3, 4, 5, 6. No, cannot include 6, right? Less than 6. That's why we just want 0 up to 5. Then 6, 7, 8. Up to 15, and the biggest value of n here is 15, so they were up to 15. So we just want less than 6, means 0, 1, 2, 3, 4, 5. Means that I taking 1. Why 1? Because the total probability for all the discrete random variable is 1, right? So that's why I minus away greater or equal 6, because outside the box we don't want 6 and above, right? So statistical table we can read if it is greater or equal 6. So look at the value here. 15, 0.1, 6. The value is 0.0022, right? 0.0022. So 1 minus 0.0022. So you can getting your answer, which is 0.9978. 0.9978. So that's your answer. Very simple, right? This is binomial distribution. I can apply binomial distribution by using this statistical table, because the number of sample here is just 15, right? So later on I will tell you why. So look at the question. The next question here will be they're asking us to find exactly 10 patients with high fever are confirmed to be free from dengue fever. Okay, you read the question carefully, right? There is a trick here. exactly 10 patients with high fever are confirmed to be free from dengue fever. Free from dengue fever. This X is suffer dengue fever, right? X is suffer dengue fever. So the question here is are confirmed to be free from dengue fever. So if 10 patient is free from dengue fever, right? Dengue fever. So then how many of them are suffer from dengue fever, right? Means the patient that suffer from dengue fever. They tell you, the question tell you, okay? You read carefully, right? So exactly 10 patients with high fever are confirmed free from dengue fever. So you have 15 people, right? You have 15 people. So the probability should be X equals to 5, right? Not 10, not 10. The reason is why. You must understand the sentence there, right? So 10 free from dengue fever means that if 10 free from dengue fever, means the remaining 5 will be suffer from dengue fever, right? This is supposed what you should do. So you can apply the formula for binomial, which is 15C5, right? 15C5. So 0.1 to the power of 5. And then 0.9, right? PQ 1 minus 0.1 power of 10. How to get 10? 15 minus 5. So this is the formula, right? So as you calculate, you are getting the value of 0.0105. As simple as that. So this is a distribution which we can using table 1. Okay, table 1, table of the meaning here is you can using the table of binomial probability, right? Okay, let's look at the next part of the question, right? Okay, let's look at the next part of this question, right? Firstly, there is only 15 patients with high fever. Now, for part B, you look at it. If 100 patients with high fever, just now it's 15, but now the number of sample getting bigger, right? Getting bigger. So you try to listen. So the sample is no longer 50, it's become 100. It's become a lot, right? It's already greater than 50. Because if you're greater than 50, you cannot using statistical book, you know. Okay, this is the most important thing here. It's too big, right? 50, okay? You see the largest n will be 50, right? After that, they are no longer, no, okay? No, so no more. So you cannot refer statistical table anymore. So, or a simple that when the number of sample is very big, so for example 1200, this one is just 100, right? It's considered big also. So we have to use some approximation, alright? We have to use other distribution to approximate this distribution. Kita gunakan taburan lain untuk hampirkan taburan ini, right? So okay, the best for this case is, that's why I have to tell you that you have to know the condition. You have to know the condition. So if you want to approach from binomial distribution, right? Binomial distribution, which is you having a number of sample and p. So if you want to do approximation, for binomial approximation, you use the normal distribution to approximate the binomial distribution. Then you have to have a condition here. First, you have to do continuity correction, because why? This is a discrete distribution. We are moving to a continuous distribution, right? We are changing it, okay? So we have to do some correction here. So beside that, there is a condition, okay? There is a condition. So where the value of NP, or we say that the value of mean, the NP must be at least 5. Alright, at least 5. Syarat dia. Okay, the number 2, the value of P must be within 0.1 and 0.9. Right? So this question, okay, you can try to find the mean, right? You can try to find the mean. So the mean is you taking n, right? N is your 100 multiplied with your P 0.1, which you're getting 10, right? 10 is greater than 5. Right? So you have passed the first condition, and the probability is 0.1. Okay, is at the border here. Okay, 0.1. So okay, it's accepted. Right? As long as your MP is greater than 5, this is a more already convincing. Okay, already can prove that you can doing this approximation. All right. But I have tell you before, the better, the bigger the n, right? The bigger the n, the better. And the nearer the p to 0.5 will be better, right? This is for your extra knowledge, okay, extra knowledge. So the bigger the n means that if the n is very big, for example, 1000, 2000, and the value of p here is nearer to 0.5, maybe the value of p here is 0.4 or 0.6, is even better, okay? It's even better. This approximation will be getting more accurate. All right, that doesn't matter for now. You just need to know what to do. So you want to do approximation, right? So because the sample is too large, so we want to do approximation. So okay, let's start the approximation. So I'm going to, all right, now okay, we want to using normal distribution as an approximation to this binomial distribution. So okay, because the condition is more than 5 and the variance, okay, I need the value of variance here. I take 100 multiply with 0.1 multiply with 0.9, so I will getting the value of 9, right? 9. So okay, now I already start approximating into a normal distribution as I know the mean, right? I know the mean will be 10 and your variance is 9, right? This is your mean, this is your variance. So okay, now have enough information. So but you always remind yourself by jotting down here, you know that okay, you need to do continuity correction once you once you're using a continuous distribution to approximate a binomial distribution. Okay, so you have to do continuity correction. Okay, so and the question is asking us to find that. All right, okay, the question, approximate, okay, they already tell you, approximate the probability that 9 to 14 patients are confirmed to be suffering from dengue fever, right? 9 to 14. When they use the word approximate, means that you need to use a suitable distribution here. Okay, just now I have discussed the condition. So this condition here is telling us that we should using normal as a approximation. So okay, they are asking us to find the probability that, all right, find the probability that approximate the probability that 9 to 14, right? 9 to 14 patients are confirmed to be suffering from dengue fever. So you cannot start converting. You cannot, okay, you then never try to changing the score become Z without doing continuity correction. You cannot do that, right? Because why? You are approximate, okay? You are approximate to normal distribution. So now what you should do is you should do some continuity correction, right? The correction here, okay, I have teach you before. So which we have to have with the help of some method here. We draw a box, right? We draw a box. So you have 9 and you have the value of 14, right? 9 and 14 is between 9 and 14. So here you definitely have 14.5. Here you have 13.5 because you add 0.5 minus 0.5. This one you add 0.5, 9.5, 8.5. There is an equal here, right? There is an equal here. Means that we will include this region here, right? In between means all the region here. So you start to shade the region from 8.5, right? So you should put 8.5 up to 14.5, right? 14.5. So this is very important when you're doing approximation, especially when you're doing approximation by using continuous distribution to approximate a discrete distribution, okay? So okay, now I can find this by converting into Z, all right? Okay, I write here equals to probability of 8.5. I want to change it become a score Z standard. So I will using the formula of X minus with mean divided by standard deviation, right? Okay, so now just minus with the mean, the formula minus with the mean. Your mean is 10 divided by square root of 9, right? This is variance, right? So standard deviation will be square root of 9. Same thing also for this, 14.5 minus with 10 divided by square root of 9. So then next, you know that the value of Z will be lies between, from calculator, it lies between negative 0.5, okay, negative 0.5 and 1.5, right? 1.5. So you already become an expert, okay? You already become an expert to evaluate this. So you know that this distribution is a standard score, right? The Z, the mean will be 0. So negative 0.5, all right? Negative 0.5. And another one is 1.5 is here. 1.5. In between is this, right? In between. So it's the same as everything minus away little bit on the left, which is negative 0.5, right? Minus away this region and minus away the region on the right, 1.5, right? As we want to be reading the statistical table, if you want to using the statistical table for matriculation, you have to change this, the left tail to the right tail, right? Reflect, okay? Reflect. So the meaning here will be the total minus with 0.5 here, okay? This one is symmetry, right? They are symmetry. So the area for this is the same as area for this, minus away 1.5, right? 1.5. So now this is in your mind, all right? This is not a working, all right? This is just for you to understand, all right? So then I have to write this. I can convert this. Everything means 1 minus away pz greater or equal 0.5, okay? Then minus away pz greater or equal 1.5. Okay, you can read this value from statistical table, right? You can read this value from statistical table by going using the table 4, right? Table 4, normal distribution. Table 3, okay? Table 3. So 0.5, 0.5 is 0.3085, 0.3085, and 1.5, okay? 1.5, 0.0668, 0.066668. So later on, calculate, okay? Calculate, you are getting the probability of 0.6247, okay? 6247 for this, right? The number of patient is from 9 to 14 patient. So I'm doing approximation, okay? And that's why I need to do a continuity correction. This one is very important here, okay? Okay, let's go on for the last part of this question. All right, okay, look at the last part of this question. Find the value of m such that the probability of more than m patient, right? More than m patient, you know that m patient, x is a discrete random variable, it represents the number of patient, right? More than m patient is more than m patient that are confirmed to be suffering from dengue fever is 0.025, right? It's just 0.025 of them. So how to solving this problem? You want to finding the value of m. So of course, definitely you need, because you are in the sample of 100 patient, right? Of 100 patients. So you have already do approximation, right? Approximation. So then you have to do a continuity correction. Continuity correction. So the continuity correction here is, I don't know what's the value here. I just put an m here, and I know that this value have to be adding 0.5 and subtract with 0.5, right? Because of the greater than, right? Greater than is the question, right? The question is saying that find the value of m such that is more than, right? More than. So more than, they are no equal. So if they are not equal here, so what to do? So you are not shaded the box here. So but it's greater than means it's on the right, right? So you start shading from m plus 0.5 and so on, right? So you have to do continuity correction for this, right? You have to do continuity correction. So it will become, after you do continuity correction, so it will become px greater than m plus 0.5, right? So 0.025, right? 0.025. So later on, after you do continuity correction, only you can start using the normal distribution, right? So you convert this become a score z. You just take the value here, x plus 0.5 subtract with the mean 10 divided by the square root of 9, and which give you 0.025, right? 0.025. So then later on, how to solving this? Okay, usually I will asking student to, okay, first you look at this. You can rewrite this to be a k, right? You can just write this to be a k. So the k is just m. 0.5 minus 10 is negative 9.5 divided by square of 9, which is 3. Okay, you let the k to be this one, right? Later on, you know that pz greater than k is just 0.025. You see the value here. You see the sign here, right? So it's greater than, right? Greater than. And it's already less than 0.5. Means the distribution is already on the right tail, right? On the right tail, because kenapa sudah dekat sini? You tengok ini 0.025 saja. Greater than. Greater than is either the big one or the small one, right? This value is so small, so definitely it's just here. It's already on the right tail. So means that you can directly read from statistical table here. You can read the value from statistical table. So of course 0.025, you can you see the number is quite beautiful, right? So you can using the table 4, okay? Table 4. So 0.025, is there any value? 0.025. Oh yes, there are. Okay, 0.025, right? 0.025. So what is the score z here? 1.96, all right? 1.96. So it means that you know that this will be, the value of k will be 1.96. So the value of k here will be the k is referred to the m minus with 9.5 divided by 3 equals to 1.96. So if you're solving this, it will become 3 multiplied with 1.96 plus with 9.5. So what is the value of m in this case here? It's 15.38, right? 15.38. So this is just an estimation, right? So for me, usually I will tell students to round off to the nearest integer. So you just round off this, you are getting 15, right? It's around 15. So we can say that this one is around 15 patients, right? 15 patients. So okay, so means that from it's an estimation. Okay, if you give 16, I also consider that as okay. All right, it's just an estimation because the sample very large, right? Okay, so find the value of m. So the m here, the value of m here, I can say it's a bit around 15. So we say that the m is 15, right? M is 15. Okay, 16 also okay. All right. So that's all for this video. Hope you understand. What the most important is to know why am I doing approximation. That's the condition that I tell you just now. All right, that's all.